When something goes wrong at work, whether it's a small mistake, a near miss, or, a full-blown disaster, the cause usually seems pretty obvious, right? Someone messed up, it's a simple, straightforward explanation. But what if it's not? Today, we're going to peel back that first layer and really look at what's going on underneath the surface. So let's dive in.
Okay, so think about industries like oil and gas or nuclear power or even aviation. Here, the consequences of failure, well, they can be absolutely catastrophic. The pressure is just immense and safety is literally everything. But here's the thing, the lessons from these super high-stakes fields, they apply to every workplace because they force us to look beyond the easy answer and find the real roots of failure before it's too late. So when you actually look at the official data, a familiar culprit pops up again and again. These reports on offshore fatalities, for example, they cite human error as a primary cause in 31% of cases. That's the exact same percentage as physical accidents like slips and falls. It's always presented as the end of the story, the final answer. But is it really?
And that right there is the central question we're going to dig into. When an investigation just ends with human error, it feels like the case is closed, doesn't it? But what if that's not the end of the story at all? What if human error is actually just the beginning of a much, much deeper investigation?
All right, so to find the real answers, we've got to move beyond the blame game. And that means shifting our focus away from the individual who made the mistake and onto the system they were working in.
You see, focusing on blame isn't just simplistic, it's actively harmful. A 2017 study of safety experts found something really critical. When people are afraid they'll be punished for mistakes, they just stop reporting the near misses. And think about that. Those small problems, those almosts, are the crucial warning signs of a potential disaster. The organization goes blind. It completely loses its ability to learn. So here's the crucial takeaway. We need to completely reframe how we think about this. Human error isn't the disease itself. It's a symptom. It's a blinking red light telling you that something is wrong with the larger system. The tools people are using, the training they got, the workplace culture, the procedures, you name it.
So what does that disease actually look like in practice? Well, it's often hidden in the culture and the structure of the organization itself. Experts point to these kinds of things, like a lack of real commitment to safety from management, not just talk, or a blame culture where the first question is always, who messed up? Or maybe it's that constant pressure to prioritize production over following the right procedure. These are like invisible currents that just pull people toward making mistakes.
And this contrast really lays out the whole new perspective. The old way of thinking? It's all about focusing on the person, blaming them for failures and then trying to enforce safety by just piling on more rules. But the new view, it completely shifts the focus to the system. It's about learning from every single failure so we can design safety right into the process, from the very beginning.
Okay, so this sounds great, right? Let's fix the system. But where do you even start? I mean, you can't analyze every single action that happens in a workplace. It's just impossible. So, we need to focus our attention to zero in on the moments that matter most.
And this is where a really key concept comes in, the Safety Critical Task, or SCT for short. Think of it as a way to pinpoint what truly matters. An SCT isn't just any old task. It's one of those moments where a single mistake, just one wrong move, could directly trigger a major accident. These are the absolute high-stakes moments we have to get right, no question.
Let's make this super concrete, okay? Here are some examples. Starting up a massive process heater, that's not like flipping a light switch in your house. One mistake there could lead to an explosion. Or think about overriding a critical safety alarm even for just a few minutes. That could totally mask a developing catastrophe. And of course, in an emergency, correctly launching a lifeboat, well, that is literally a matter of life and death. You see, these are safety-critical tasks.
So now we know where to look, right? We're focusing on these safety-critical tasks. The next logical question is, how do we look? We need a systematic way to analyze them. It's kind of like a detective's toolkit for finding hidden risks.
And that toolkit has a name. It's called Safety Critical Task Analysis, or STA. And I love this analogy. Think of it like an MRI for a work process. It's this powerful diagnostic tool that lets us look deep inside a task, see all the moving parts, and find those hidden vulnerabilities. The weak spots where things are likely to go wrong, and we find them long before an accident ever has a chance to happen.
And this isn't some mystical, complicated art. It's a really logical process. You start big by identifying the major hazards.
Then you zoom in, finding the critical tasks that are supposed to prevent them. And then comes maybe the most important step of all. You have to get out there and see how the work is actually done. Not just how the manual says it should be done, but what happens in the real world. From there, you can map the task, pinpoint the exact failure points, and finally build in better, smarter safeguards.
So how do you actually map a task like that? Well, one way is with something called a hierarchical task analysis. Now, it might look a little complex at first glance, but the idea behind it is actually super simple. You take one big goal, in this case, manually activate blowdown, and you just break it down into smaller and smaller steps. Like see how diagnose event branches out into checking the location, the size, the status. This process lets you analyze every single tiny action for hidden risks.
Okay, so we've mapped out all the steps. Great, but what could actually cause someone to fail at any one of them? I mean, why would a mistake happen? To answer that, we need to look at another key concept, performance influencing factors, or PIFs. And these are basically all the hidden conditions that can make errors more or less likely to happen.
So let's break down what these factors actually look like. They usually fall into a few buckets. You've got factors related to the job itself, things like really unclear procedures, or maybe just poorly designed equipment. Then you have person factors, stuff like fatigue, stress, maybe their level of experience. And then, so critically, you have the organization factors. This is the big one, that relentless pressure to put production over safety, or a real lack of good supervision. The thing is, these aren't isolated issues. They all combine and interact to create the very conditions that can set a good person up to fail.
So what's the real payoff here? Why go through all this analysis? Well, it's about making a fundamental shift in how we build our workplaces. It's about moving away from that endless cycle of blame and reaction and moving toward a proactive process of building better, safer, and way more resilient systems.
And here's the bottom line. The goal isn't to create perfect, error-proof humans. I mean, come on, that's impossible. The real goal is to create systems that are error-tolerant. Systems that are designed with the absolute expectation that people, being human, will make mistakes. And because we expect it, we can build in safeguards to catch those mistakes before they ever have a chance to escalate into a catastrophe. It's all about designing for reality, not for some impossible idea of perfection.
And that really leaves us with a final thought. This whole idea, it isn't just for massive industrial sites. It's a mindset that you can apply literally everywhere. So the next time you see a mistake at your job, at home, anywhere, I want you to think about which question you're going to ask first. Is it going to be the easy one, who messed up? Or are you going to ask the better, more powerful question, what allowed this to happen? Because the question you choose, that makes all the difference.